Environmental water samples are often extremely dilute. How critical is concentration to reaching your detection limits?
So if there's anything you must not play with is concentration. If you don't concentrate it, you will not get anything. And so when we are concentrating it, we are very careful and you don't want to rush the concentration. If you rush the concentration, there's possibility, like I've said, these things are volatile. There's possibility that you lose most of this PCB and all what you'll be seeing is not detected. So you do it gently. For instance, when we are using rotary evaporator, we try to ensure that we don't use high temperature. We ensure that we don't dry completely.
And that was a big question I had because I did notice that you utilized both a rotary evaporator as well as nitrogen blowdown. So I was curious to hear how both of those techniques worked well together in concert.
So generally, when we are using large volume, you want to concentrate down, we use rotary evaporator. So after we want to recover our stuff from the rotary evaporator, we use another solvent to recover it. Then we now use nitrogen blowing to concentrate it down so that we now use that to prepare it for our GCMS.
And you noted that you didn't go all the way to dryness. Do you remember offhand how low you took the volume down?
Yeah, I think if I can remember, we always try to ensure that it's less than 1 mil. Yeah, very small amounts. That's what we normally.
For labs setting up similar methods, what practical tips would you give for solvent reduction without analyte loss?
I will always tell them that they should be careful with their temperature. They should not use high temperature, and they should pay attention when they are doing concentration because that is where many people, miss it.